teacher.
Hey guys, in this lesson we're going to be reviewing 5.2 graphing and also 5.3a rearranging. It combines both skills in those lessons. So in the exit slip last week you got this question and I'm going to rearrange it and then also graph from that answer. So the first thing you had to do was isolate for y by getting rid of the x variable as well as the constant if that was the case, and you do that by doing inverse operations, which is in this case subtracting. So I'm going to subtract 7x and subtract 10 on both sides. Some of you wanted to do this in 2 steps and that's fine. 7x minus 7x is 0, so those go away. 10 minus 10 is 0, and so I'm left with 2y equals 0 minus 7x minus 10. Many of you would also realize that you didn't need this 0. You don't have to recopy it. But if you like doing that, that's fine. So you'll get a simplified version of 2y equals negative 7x minus 10. And then the last thing I have to get rid of is this coefficient of 2. So how do I get rid of coefficients? It's 2 times y, so then the opposite would be dividing by 2 for the whole thing. And then your final answer would have been y equals negative 7 over 2 x minus 5, because 10 divided by 2 simplifies to 5. So most of you got this from what I saw, which was great. And then you would have identified that the slope is negative 7 over 2 and the b value is negative 5. Please keep in mind, remember, x tells you which number is slope, but it's not part of the slope. The slope always has to be a number. So the new stuff, or the kind of new stuff, is graphing from this point. So I always start at my y-intercept, which is this b value. So the y-intercept is at negative 5, so I'm going to put a dot at negative 5 for the y-axis, not the x-axis. And then I need to go up 7 or down 7 and up left and right 2. So I can't go down because then I'm going to run out. So I'm forced to go up 7. 1, 2, 3, 4, 5, 6, 7. And in order to make it look like it's negative, going down to the right, I have to go to the left 2. 1, 2. And then when I plot my point that way, it's forced to go to the bottom right. And then I would have graphed my line correctly like that. And then I'm going to include my arrowheads for proper form. So this was the only sort of new thing, although you already know how to graph, and that's what your graph looks like. A different example, x minus 2y equals negative 6. I have to do the same thing. Isolate for y by getting rid of the x by, in this case, subtracting. So minus x on both sides. And then I'm left with negative 2y equals negative 6 minus x. And then to get rid of the negative 2, I have to divide everything by negative 2. And I would have gotten negative 2 divided by negative 2 cancel out to just positive 1y, or just y. Negative 6 divided by negative 2 is positive 3. And negative x divided by negative 2 is positive x over 2. And I asked you guys if you have x over something to rewrite it with that imaginary 1 next to the x. Some of you did forget that this week, so try not to do it here, and rewrite it as half x plus 3 as your rearranged equation. So here the slope is half, the b value is 3, and now I can start plotting my points. So this is the y-intercept. I'm going to go to 3, and then because it's positive, I can go up 1 and right 2. So 1 here, and then 1, 2, whoops, I went too many. Up 1, and then 1, 2, so that's another point. Or I could have gone down 1 and left 2 to make it positive. Then I have my 3 points, so I can connect the dots and have a straight line and include arrowheads on both sides for proper form. Not so bad, right? Okay, one more example and then it's going to be done. This looks really simple, x plus y equals 0, but this actually gets a lot of students. They're really good with the rearranging. They subtract x on both sides and they say y equals negative x, which is great. But then they tell me the slope is equal to negative x and the b value doesn't exist, but that's not the case. Remember, there is that 1 with the x. So slope is negative 1. And the b value, it does exist and it's at 0. It's a direct variation and it's crossing the origin because it's like saying plus 0, but it's redundant. So when I graph this, I start at the origin and then I have to go down 1, right 1, or I could have gone up 1, left 1, because again, negative slopes have to go down to the right. So I've got my 3 points, I can plot it, and then that's how you graph lines in standard form. You always just rearrange it first, and then you graph it with starting at the y-intercept and then doing the slope. Just a friendly reminder, a refresher of parallel and perpendicular lines. If you had a line that was parallel to this, parallel lines are the same slope. So an example of a line that would be parallel could be y equals negative x plus 10, because the negative 1 is still there. And then if you had a perpendicular line, you had to have the negative reciprocal slope. And if you remember what negative reciprocals were, if I had like 1 over 3, then the negative reciprocal is negative 3 over 1, which equals negative 3. Or if I had 5 over 7, or let's say negative 5 over 7, the negative reciprocal would be positive 7 over 5. Just do a refresher because we do check for parallel perpendicular in the exit slip again. If you couldn't remember parallel perpendicular, just go back to the 5.1 summary of concepts or rewatch those videos. That's it. Have fun.